Hello, welcome. In this video, I'm going to explain about conditional probability. Conditional probability is a probability of an event given that another event is occurred, and it is denoted as this one. And we read this as probability of A given B. So the given condition is B, and that is calculated as the probability of A intersection B divided by probability of B. Please note that the denominator is the probability of the given condition. So in this case, the event B is given. So the probability of the event B will be the denominator. And also probability of the given event has to be different from 0, because if it's equal to 0, then this expression will be undefined. So the formula is derived from the empirical definition. In the next few minutes, we are going to see some examples of conditional probabilities. And we will also use R to calculate conditional probability. And so in this video, we will only see examples related to conditional probability. In next video, we will see bias theorem. Okay, so in this example, it says the following. A company's workforce consists of 60% men and 40% women. Among them, 20% of men have a master's degree and 50% of women have a master's degree. If an employee is randomly selected, what is the probability that A, they are a man with a master's degree, B, they are a woman with a master's degree? When I say they, represents he or she, okay, here. So to calculate the first one, which is the probability of a man with a master's degree, what is the condition? The given conditions are as follows. Let's M is an employee is a man. W is an employee is a woman. And probability of M from the given one, how much it was? That's 0.6. Probability of W, it will be 0.4. The probability of a master's degree, given that a man is 0.2. Yeah? And the probability of a master's degree, given that a woman is 0.5. These are the given ones, and we are asked to calculate. A is the probability of M intersection D. B is to calculate probability of W intersection D. From the conditional probability definition, we can calculate probability of D given M is probability of D intersection M divided by probability of M, because always the probability of the given event is the denominator. So from here, to calculate probability of D intersection M, we can use cross multiplication, then probability of M times probability of D given M. So that is probability of M here is 0.6 times probability of D given M is 0.2. So that is 0.12. So A is 12%. What is this? This is given us probability of D intersection W divided by probability of W. And that implies this is already 0.5. So 0.5 times probability of W is probability of D intersection W. So probability of W is 0.4. 0.5 times 0.4 is probability of D intersection W. And this is 0.2. MB is 20%. We can also use R. R is a statistical tool that you use to do statistical analysis. And we can just copy this one into R. I'm going to show you how to do this. Okay, I am going to use RStudio. I will assume that you know RStudio. Can you see it? Okay, so what I can do is probability of M is 0.6, probability of women is 0.4, probability of a master's given a man is 0.2, probability of a master's given a woman is 0.5. Then I can run and then show you the result. Huh? Let me just run this. Run. The result, you can see it here. Huh? And then run, run. So I'm going to now print the result. The result will be 0.12 and then 0.2. So I'm just using the formula to calculate the probability. So nothing else. It's just like using a calculator. Huh? Okay, now let's go to the next example. The next example is the following. For a student enrolling as a freshman at a certain university, the probability is 0.25 that he or she will get a scholarship and 0.75 that he or she will graduate. If the probability is 0.2 that he or she will get the scholarship and will also graduate, what is the probability that a student who receives a scholarship will graduate? For a student who got a scholarship, let's denote as S. And for a student who graduates, let's denote it as G. So probability of S is 0.25. Probability of G will be 0.75. And the probability of the intersection is 0.2 is given. And we are asked to find the probability that a student who receives a scholarship will graduate. So the given condition here is the student receives a scholarship. To calculate this, we can use the conditional probability formula. Probability of G given S is probability of G intersection S divided by probability of S, because S is given. Then from the given one, we know probability of S is 0.25. Probability of G is 0.75. And probability of S intersection G is 0.2. That's the given. So it's just substituting in this equation. So the intersection is 0.2 divided by probability of S is 0.25. And that is 0.8. So let me just show you in R. This is this one. I'm going to run this also. Control plus enter. And the intersection is 0.2. And the probability of G given S will be 0.8. So the calculation is correct. Now let's go to the next example. If the probability that a research project will be well planned is 0.6, and the probability that it will be well planned and well executed is 0.54, what is the probability that it will be well executed given that it is well planned? So the given one is well planned. So suppose probability of well planned is 0.6. The probability of well planned intersection well executed is 0.54. So suppose well planned is A, well executed is B. So here means probability of A is 0.6 and probability of A intersection B is 0.54. Then we are asked to find probability of B given A. The probability of well executed given that is well planned. And that's just probability of A intersection B divided by probability of A, because that is a given condition. Then 0.54 divided by 0.6. And that's 0.90. And in R, we can also do this similarly. So this is like this, like this, like this, like this. So probability of B given A is 0.9. Additionally, it's optional, but we can also see the intersection using Venn diagram like this. So this is a Venn diagram. We can also visualize it, the intersection, the area for A, the area for B. And this is our example of visualization and example of calculating conditional probability. So one last question is the following. Suppose we have 2 red and 3 white balls in a bag. If we draw a ball without replacement, find the probability that A, the first draw is red. B, the second draw is red, given that the first draw is red. And C is the second draw is red. So suppose we have 2 red and 3 white balls in a bag. In total, how many balls do we have? 5 balls. If we draw a ball without replacement, so we are not replacing, they are dependent. The next draw is dependent on the first draw. We have 2 red and 3 white balls. We have how many draws? 2 draws. So we may draw red, red, or red, white, or white, red, or white, white. If we denote these are R and this as W, or we can also use capital or small. So A says, what is the probability of the first row is red? The probability of the first red. This means either it can be probability of red, red, or the probability of red W. Yes? Okay. What is the probability of red, red? They are dependent. I have how many reds? 2. Divided by, in total, 5. Times. What is the probability of red? Because the first red is already taken. So what is the next one? It is 1/4. Because 1 is already taken. Plus, here, 2/5 times W. So W is 3. divided by 4. And then you add this. So this is 2 over 20 plus, and this is 6 over 20. And this is 8 over 20. And this is by 4, 2 by 4, 5. And 2 over 5 is 0.4. So the result will be 0.4. What about for B? B says the second row is red, given that the first row is red. The probability of red given red, that is 1 over 4. And C, the second row is red, means probability of red, which is the second is red, plus probability of W red, where the second is red. And that is probability of red is 2 over 5 times 1 over 4 plus this is 3 over 5 for W times 2 over 4, because the 2 R's were there already. And this will be 2 over 20 plus 6 over 20, which is the same with the first one, 8 over 20. And then by 4 is 2, by 4 is 5, and this will be 0.4. So for C is 0.4. And yeah, so this is all about conditional probability. If you have any question or any suggestion, you are welcome. Please like and share and comment. And yeah, thank you very much. See you in the next video about bias theorem.